Welcome, everybody, to another episode of our Ecumen Podcast. The clinical education team is joined today with clinical consultant pharmacist Melanie Proctor, and she's here to help give us some information related to COVID. And Melanie, I have some questions for you specifically related to variant information and maybe help clear up some confusion related to that. Can you tell us a little bit, just as we hear about all these variants, how does a virus mutate?
Sure, that's a good question, Jesse. So when a virus mutates, it's actually it happens during the replication process. Viruses are replicating all the time. And so what happens is when they replicate, then the end copy will end up having a difference either in the DNA or the RNA. And those are actually what the mutations are. So you could think of it like a typo in a manuscript. So you're typing A, B, C, D, and it actually accidentally comes out BACD. So it's the same content, but just in a different sequence. And when that happens in a virus, then that's considered a mutation.
Okay, that makes sense. It's an interesting way to think about it. So can the COVID virus currently, can it continue to mutate? Will we see more mutations?
Yes. Anybody that's knows anything about the viruses, any epidemiologists, we all predicted that this would mutate. It's just something that viruses do because they replicate so fast. It opens up more opportunity to mutate. So I don't think COVID's going away anytime soon, just like influenza never went away and polio never went away. So every time it mutates, it has the opportunity, or every time it replicates, it has an opportunity to mutate. And it needs a host and it needs to be inside of a cell to actually replicate. So the more times that it infects somebody, the more opportunities that it has to mutate. So I don't really see this going away, these mutations.
Okay, sure, that makes sense. So you talked about how viruses can mutate rather rapidly. Is there any way that we can help kind of slow down these
Yes.
mutation rates?
Yeah, good question, Jesse. So in order, like we just said, that it needs a host and it needs to be inside of a cell. So if we can slow down how many people are getting infected, then that slows down how many opportunities that it has to mutate. So through vaccines, our social distancing, hand washing, and wearing our masks, and anything that we can do to prevent the spread will slow down any mutation that's going to occur.
Okay, well that makes a lot of sense and probably really, really good to know that we can all play kind of a part in slowing that down. And I know we've
Absolutely.
heard a lot in the news and in social media about different types of variants, certainly the Omicron. Now, is this like worse than the previous strains? Do you know?
Well, I wouldn't say that it's worse. I mean, I think we've had enough time now to say that it's more easily transferable to other people. So it's from person to person, but it is less likely to cause a severe illness, which is good. But it did
Yeah.
put a strain on our healthcare system, because we had so many cases at the same time, because it was more contagious. So depending on how you look at it, it's worse in the fact that everybody got sick kind of all at the same time. But the good thing was because of this mutation, it caused less severe illness. And then also the vaccinations definitely helped to reduce the severity or the
Yeah.
likelihood that a person would experience symptoms.
Yeah. Okay. Very interesting. Thank you.
I
Yeah,
I
it's
have
like this isn't going away, right, Emily? So you were going to talk to us about vaccines and have some questions related to that.
yeah, and just to kind of circle back to what we were just talking about, I'm curious of, when we're talking about how it mutated and replicated that, um does it happen where with every mutation it would get kind of like weaker and weaker and weaker, like kind of like survival of the fittest kind of thing, where
Exactly.
is
Yeah,
that what it's
that's
kind of like?
that's excellent. Excellent to ask that, Emily, and I kind of see where you're going. So basically, it can be a random mutation, which may make it a more virulent or more severe illness. It can make it die, and maybe a strain will just go away because of a mutation. We like to think of it as branches on a tree. So if you think about a tree, and every branch that comes off looks completely different. There's different size leaves, and maybe some leaves go up toward the sky and others point down, or then you'll have a branch that just dies off. So you could think of every branch of a tree like a mutation. Of course, there are inherent abilities within the virus that will also mutate to like go around a wall. So let's say that our vaccine is a wall. So it'll get in, and it gets into the body, and it can determine based on our defenses how it's going to mutate to get around all these things. So is it going to mutate to get around the vaccine, or is it going to mutate to get around something in our immune system that's kind of blocking it? So the more opportunities that it has to get into a person's system and kind of see, okay, I'm going to switch this and do this. So they are smart, and it's not always random in the mutation. Sometimes it's actually mutating, like you said, Emily, to be survival of the fittest.
Sure. Yeah. So there isn't really a guarantee every time of this mutates. And yep, it's always going to be weaker. No, it actually might be a really strong, powerful, branch, like you're saying with a tree analogy. And is there a way to predict that? If
You
it'll
know,
be
really,
stronger or weaker?
no, there really isn't a way to predict
Yeah.
it. There are different stages that they classify. So there's a mutation, and then there's a variant, and then there's a strain. So a mutation is when you see a few little things that are different about it. And a variant happens when you see an accumulation of enough mutations into the virus that you have a variant. So Omicron is a variant that was due to a mutation. And it's mutated so many different times into Omicron. Now they call it a variant. But then you can also, through these different mutations, and then you get a variant, you can actually come up with a whole new strain. Now, this has not happened with COVID, but when a strain happens, it can actually have different biological capabilities. So it can actually cause different symptoms or spread through a new route. And when that happens, they label it a strain and not a variant. But there hasn't been a new strain of COVID as of yet. But time will tell. We really don't know. It's kind of like watching a football game, right? You don't know what's going to happen at the end.
Yeah, exactly. As is life, right?
Exactly.
And it kind of sounds like too, influenza A, influenza B, right? Those are two different strains.
Yes.
Okay.
That's a good example. And it's no different than influenza. It actually, what they've seen, and this wasn't a surprise, but just the way a coronavirus is, it actually mutates slower than an influenza does. So I know we've been focusing on all these different variants that are coming out with COVID, but there are thousands of different variants of influenza, which is why we now have influenza A and influenza B, and we have a vaccine for that we have to constantly update because it replicates so fast that we're constantly having to keep up with that, and the vaccines don't work from one year to the next. And so we have to basically reinvent the vaccine, which we haven't had to do yet with COVID. So we were going on 2 years. Of course, the vaccine wasn't out the whole time, but we haven't actually had to recreate or alter the current vaccine. It's still working. So that's the positive that we're seeing with COVID, is its ability to replicate is much less than an influenza virus.
Yeah. And that's great to know. I mean, that I guess is, a silver lining we can take
Yes.
away from this. But all of this information, it kind of breaking it down with these details, I think will be helpful for people just kind of wrap their minds around that a little bit more. So thank you for sharing that.
You're welcome.
I want us to kind of move into a little bit more about the vaccines. We've already kind of touched on that. So, we hear it all the time, right, from the CDC and our local entities that they're encouraging, what are all these ways that we can do our part to protect ourselves, or, especially us working in healthcare with our olders and elders. How can we protect them and ourselves? And, we hear vaccines are really kind of that gold standard. Um, so if you want to talk a little bit about that and maybe just other ways we can protect ourselves and in our residents.
Yeah. Well, I think, vaccines are a big part of this. Um, and if it right now we just have that one additional booster, unless you're immunocompromised, then there's a second one. But if they were to come out and inform us that we need to get another booster, or that they had to change the vaccine a little bit to, you know, help against a different strain that might come out or a different variant that might come out, I would encourage people to continue to do that, because the more people that continue to get their vaccines, the less likely we are to spread it or to slow the spread down, and hopefully reduce how many people are going to get illnesses that would put us into the hospital. But then also, again, using your distancing, wearing your mask. Right now they're saying an N95 or a KN95 is better than like a cloth mask, just because the Omicron variant was so contagious and it was just getting through the big gaps in the homemade masks and things. And then, of course, to get the self test if you're going to be indoors or in close proximity to somebody. So if you're going to do some kind of a gathering with your family, and you have people that are maybe a little bit more at risk, you might want to consider getting yourself a self test and testing before you go, just to make sure that you don't have it. But all those things will help reduce the spread, and then in reducing and slowing the spread will reduce the chance that these vaccines are going to become um, uh, resistant, I guess is the word you could say, against any new mutations or variants that might come out.
Right, right. Yeah, and like you said, with any kind of virus, we can expect that mutation is going to happen. So, of course, the vaccine, itself will maybe each year or so on and so forth will have to continue to kind of, adjust as well with what we're seeing.
That's right. And there are epidemiologists behind the scenes that have been studying this from the beginning, and they are actually constantly watching the variants that are coming out. Like, we all knew Omicron was coming before it was ever here. Um, so, there's all kinds of variants that they're monitoring. There's alpha, beta, gamma, eta, lambda, epsilon, kappa, zeta. And then Delta and Omicron were just the ones that happened to get on the concern list. And then there's also a category of variants of high consequence. And we don't have any of those for COVID at the moment, and hopefully we don't. But just so you know, there are epidemiologists worldwide that are tracking these things. And this tracking will allow us to update the vaccine if need be, and hopefully before that would ever get to the US in great numbers, and we would have that updated vaccine available. And that's why it's important to keep your eyes and ears open to what's going on. And if a new booster or a new type of vaccine comes out that we need to get, it's just important to do that to help slow the spread of whatever the next thing might come out. And again, this is no different than what influenza's been for years and years and years. And that's why we've always had such a big push to get the influenza vaccine, is because for those people that are at high risk, in us getting that vaccine, it helps reduce the risk to them. So this really isn't anything new in concept. It's just new in what kind of virus it is.
I think that I was just going to say, I think that's a really great point, because as you're just sharing all those different variants and strains, it can kind of sound ominous, but thinking back from last year around this time, we are really leaps and bounds ahead of where we were a year ago. Do you agree with that? Or
yes, I think
okay.
the 2 years that we've had to be able to research this has just been huge. And the fact that and maybe we're jumping ahead, but we're getting into the positives, right? Of where we're at now, and what's positive about it is, we are vaccinated, or if we're not vaccinated, maybe we were exposed and we have immunity. We had none of that back when this all came out. And that to me was the scary part of COVID in the beginning, was no human being had ever been exposed to that before. So nobody had any immunity to it. Now we do, either through a vaccine or whether you were exposed to it. But that doesn't mean it's going to go away, because they're smart and they're just going to keep switching and changing and getting around all of our roadblocks that we put up for it. But we also have these scientists now that are aware of COVID. They know how it works. They're understanding it. They can probably foresee things a little bit. They have a bunch of genetic mapping that they're doing on COVID that we didn't have 2 years ago. We didn't have any of that.
Absolutely.
Yeah.
Yeah, Trish, go ahead did you have another question, Trish?
No, Jesse,
no.
did you have something else that you wanted to ask before we wrap
Well,
up here?
Yeah, sure. I was listening to something the other day, and it related to that herd immunity that we kind of touched on, and how getting the vaccine to a greater number of our population is going to just increase the chances of controlling the COVID virus going forward in the future. And I thought one of the positive notes of that was that, we're now starting to vaccinate children too. And so we're increasing that number of population for more and more people having a little bit more protection against this spreading. And then I also heard that vaccines for the under 5 years of age will be coming out hopefully sooner rather than later. They're really close to having that as well. So I thought that was kind of interesting as we strive towards that herd immunity.
Yes, they're all definitely positive things. And again, it's important to vaccinate the children, because obviously they're not as good at hand washing and wearing masks and those kinds of things. And we all know that, you were around children, and that's typically where you're going to get sick, right? Because their little hands are dirty, and it's just hard. They're putting their hands on their mouths and things. So that'll definitely be another great step once those studies are finished, and we can roll it out to the general population.
Yeah, absolutely. I giggle, don't I know it? That children could be little spreaders of these viruses. So yeah, great points.
And just to kind of wrap us here in a little bit, I again thank you, Melanie, so much for your time, really being kind of this subject matter expert. I feel like I could ask you questions all day, just out of kind of curiosity and
Sure.
and
You're
whatnot. But one question that we do get quite a bit is, if I already had COVID or I've had it twice, am I better protected from developing it again? And I think we kind of know the answer, but again, now that we've talked through it, but what are your thoughts on that when people ask, well, I have COVID, so why do I need to get vaccinated still?
Sure. And that's a great question. And I understand why people ask. Yes, you're better protected once you have it than if you've never had it before, because now your body recognizes it and it's made some antibodies, and it will recognize it again, as long as it hasn't mutated too much to the point where all your defenses don't work anymore. But the problem is, and again, we're only 2 years into studying this, is, unless you go in and get tested, you don't know what your antibody levels are. And then if you do go get tested and test your antibody levels, we don't have any reference as to what it means. So, I guess the question that we still are looking for answers to is, how long do the antibodies last? So you can go in now and get tested. So say it's been 2 weeks since you had your symptoms, and you go in and you have antibodies. Well, one, there's nothing that's come out from any healthcare source that says, well, if your antibody levels are this high, then you're not going to get it. And then two, for how long are you going to have antibodies? So you could test in a week or 3 months, and then now they're lower, or maybe you don't have them anymore. So that's where they're saying to go ahead and get vaccinated anyway, because we're going to be doing these vaccines on a routine basis. And eventually that's all going to, play out, and it's going to be just like the influenza vaccine. And we're going to have the data we need to determine how often we need to get it. But if you're just getting sick with it, we don't know how long it's going to last. Just like we're not really sure how long the vaccine lasts, and we're still doing the research to determine that. And so for that reason, yes, you get antibodies, and I think that's a great thing. But for how long are you going to have them? And that's why some people have gotten sick twice, right? So maybe they got sick and were vaccinated, and then they got sick again, or maybe they just got sick twice and never got the vaccine. But it's not that they never developed antibodies, but maybe they didn't get the antibodies up so high that they weren't prone to getting it a second time. Or maybe their antibodies fell off so quickly that they got re-exposed and then they got sick again. I hope that made sense.
Yeah, no, it absolutely did. And it makes sense, looking at like, vaccines that have been around, tetanus shots or whatever, whooping cough, things where like you do need boosters every now and then because, those antibodies have gone away. I don't think that's always common knowledge that these antibodies, can deplete, and that's kind of that purpose of the booster.
Right. And your body, the reason your body doesn't sit there and make antibodies all the time is it's just the body is a very efficient machine. So if you're not being exposed to something on a at a
Regular basis.
on a regular basis, thanks, Emily, then your body is going to say, well, you know what, I'm just wasting my energy making antibodies or making a defense against that because I don't see it anymore. And pretty soon your body just kind of dwindles away and it doesn't do that anymore. So one, you don't want to totally isolate yourself and never ever get out into the world, because that, again, I guess I just exposed that, right? That if you're holding up in your house and you're not ever getting out and ever doing anything and getting exposed to germs, it's actually going to weaken your immune system. But there's a fine line that we can ride here with this. You're going to get out, you're going to do you're going to go for walks so that your body, you're still exposing yourself to certain things. But when it comes to COVID, because we don't have a lot of defenses against it, you just want to, and some people don't have any defense against it yet, then you want to do your social distancing, your vaccines, wearing your mask, and then checking yourself to see if you're infected or not, if you're going to get within a close group. But it really is the body's way of is storing energy or not expending energy on something if it doesn't need to. And that's why the antibody levels will just drop.
Yeah. No, that does make sense. And it's kind of like use it or lose it kind of thing.
Exactly. And that's with everything. That's not just with COVID. That's with any virus or any disease that we build antibodies to. It's good. Your body reacts the same way. It's not just specific to COVID.
Yeah. No, that makes sense. And one kind of final just wrap up here with, what would you say just in general, Melanie, what is Ecumen's, responsibility, surrounding all of this, and what would you say? I know that there really could be so many directions we would go with maybe responding to that, but just overall, what's the stance that Ecumen is kind of supporting and taking with all of it?
I think Ecumen, they're trying, part of the problem with this whole COVID thing was that it became very political. And so Ecumen we have mandates in certain sectors of our Ecumen group that has to get the vaccine now because it's a government mandated thing. But then we're not extending that in to where the government hasn't mandated it, because there's also a humanity issue part of this where everybody has a right to their own feelings on how they're going to handle protecting themselves against this. So Ecumen, I think, has played a really nice stance in that, okay, we're mandated in certain areas and this is what we have to do, because if we want to continue on and not get fined by the government, then these people need to be fully vaccinated. But if we're not mandated, we encourage it because we want to protect our residents. But then we also have that humanity piece of it where we have to understand that everybody has their own feeling and their own beliefs. And I think they're trying to be very sensitive with that and walk a fine line between protecting our residents and then having an understanding for where our employees have their stance and beliefs.
I think that's a really great way to lay it out. Ecumen is generally so supportive of all of our team members. So this has been so wonderful, Melanie. Thank you so much. So informative. We could ask you a million more questions, but
So, you're
we thank
welcome. It's been fun.
yes, we thank you for your time. Thank you,
Thank
everybody.
you.